Hey there, so we're going to have a look at prisms and cylinders and the volumes that they have, okay? Now you should hopefully know that a length times a length times a length gives you a volume, okay? Now those lengths actually, they have to be perpendicular, or they'll have to be right angles to each other, okay? So when you're working out an area, for example, you always multiply together perpendicular lengths. They're at a right angle, okay? Well, if I multiplied it by a third perpendicular length, then you'd have a volume. Okay, so a length times a length times length gives you volume. And actually, I could take this here and I could say, well, actually, I know a length times a length, if they're perpendicular, gives me area. So an area times a length also gives you volume. Okay, so we're going to use that when we're looking at these shapes here. So here's a few examples. Now what's special about these shapes is that I've got an area, and the whole shape is this length that's perpendicular to that area. Okay, so it's at a right angle to that area, and that's important to be able to do this. Okay, this is why this formula only works for these shapes. Okay, we call them prisms and cylinders. So this is a little formula. Okay, the volume of your shape is going to be equal to the cross-sectional area multiplied by the length of that shape. Okay, and it's the same for all these here. So whatever this area is, and then you multiply it by its length. And again here as well, this area, and you multiply it by its length. So for this shape here, let's say we had these lengths, like the base and the height. You could do base times height, and then you could multiply it by the length. Okay, here for the triangle, you could do base times height, and then you'd have to halve it, wouldn't you? Because that's what it is for a triangle. You have half of the base times the height, and then you multiply it by its length. Okay, and that'll give you the volume of that shape. Now this is a cylinder. Now let's just do this together. Okay, let's work out another formula for the volume of a cylinder a bit more specifically. Okay, so here's my cross-sectional area. It's a circle, isn't it? And I'm going to multiply it by this length. So you might come across this formula. It's written like this. So you'll say that the area of the circle on the front. Okay, so let's say that this is the radius r. Okay, we'll have pi r squared. That'll give me this area, and then I can multiply it by L. Okay, so you might say something like that, maybe in a different order, maybe L pi r squared, or pi r squared pi r squared times L. Okay, so this is the volume for a cylinder. Okay, it's exactly the same as this. Okay, exactly the same. Cross-sectional area multiplied by a length. So I've just called it L for length. Okay, right. Let's have a look at some examples then. So here I've got a prism, and this shape on the front, I could, if I wanted to, I could split it up, couldn't I, into a square and a triangle, and I could work out this area that way. But also I can recognise that this has got two parallel sides, so this is a trapezium. Sorry, one pair of parallel sides. Okay, so it's a trapezium. So let me work out first of all the area of this trapezium. Okay, so I know that the area of a trapezium is half a plus b times h. Okay, and whatever that area is, I'll put the numbers in a second, but we're going to multiply that, aren't we, by the length, and the length there was this one here. Okay, so length, let's call it L for length. Okay, let's put some numbers in, okay, because we know this gives us volume, and that's what we want to work out. So a half a plus b, so a and b, there are parallel sides, so this length and this length. Okay, so this is the same as that number, so we've got 3, and we've got this number on the bottom here, 5. So 3 plus 5, and then I have to times it by the perpendicular height. So the perpendicular height is at a right angle to the base, is 3. And then I need to multiply that by the length of the prism, and the length here is 2. So I can do all this. Let me try and do it in my head. So we've got 8. Half of 8 is 4. 4 times 3 is 12. 12 times 2 is 24. So my answer will be 24. And what will my units be? This is all in centimetres, and it's a volume, so it's centimetres cubed. Okay, there we go. Right, let's have a look at a cylinder-y kind of example. Now this one's, I've gone for like quite a difficult example here. What I've tried to draw, this shape here, this is like a straw. You know how like a straw's got like it's a tube, isn't it? And it's got it's hollow down the middle. So imagine this is the designs for a metal straw. Okay, so this is like we're looking down it. Okay, we're looking down the straw here. Okay, these measurements here are the radius for the small circle and the big circle. So the radius for the small circle and the radius for the big circle. Okay. Now I want to know, if I want to know the total volume of metal required, let's say I'm the factory person and I want to know how much volume each straw contains of like metal, okay, I'm going to have to work out this cross-sectional area, and then I'm going to have to multiply it by the length. Okay, so let's have a think about how we can get this area, how we can make it using what we know. So what I've done is I've drawn a little picture down here just to help give you an idea. If I want to know what the area of that ring is, I can do the total area of the big circle and take away the area of the small circle, and that will leave me with that area. So let's do that. So the big circle has an area of pi r squared, so pi times 3 squared. Okay, so that's the big circle area. And I'm going to take away from that pi r squared, so pi times 2 squared, because 2 is the radius of the smaller circle. Okay. Tell you what, let's pop that in my calculator and see what we get out. So that's going to be 9 pi, take away 4 pi, so that'll give me 5 pi. So 5 times 3 is about 15, isn't it? So it's going to be about 15. Let's have a look. 5 times pi. 15.7, and I've rounded it there, but to be honest, let's not round it just yet. Let's keep this 5 pi, okay, because 9 pi take away 4 pi is 5 pi, isn't it? Okay, so I want to multiply that length, don't I? I need to do that area. I need to multiply that area by a length. So I'm going to multiply it by 150 to give me the total volume. Okay, so remember we're doing an area multiplied by, or I should say cross-sectional area. Okay, multiplied by this perpendicular length. Okay, so let's do that on my calculator. So I'm doing 5 pi and I'm multiplying that by 150. And what do we get? Let's see. I've got 2,356, and I'm rounding it here, millimeters cubed. Okay? So just to recap there, we worked out an area, and we did our cross-sectional area multiplied by a perpendicular length. Okay? And that is how you kind of work out the area, the volumes of prisms and cylinders and any other kind of strange shapes that they throw at you, as long as that length is perpendicular.
Joash Maths.